Alright, our second lesson is going to be covering DNS as a topic, but there's not as much content that I can really display on the screen and walk through live because a lot of this is going to be theoretical. So we're going to do the super boring solution here, and I'll probably host a PowerPoint to go over a lot of the content. I'd like to do a whiteboard session, but I don't have my whiteboard set up, and I also don't have a monitor that can act well as one, so we might figure that out later. But we're going to we're going to back over some DNS basics, just review the 101 stuff, the different elements of DNS, like the different types of records, what DNS is used for. I'm also going to have a section that talks about IPAM or IP address management because that is often how enterprises manage DNS. It's paired very closely with DHCP and they'd rather have a single view of everything, so we're going to cover that as a topic. I'm also going to have a small section about unique DNS situations that you might encounter in an enterprise. That's going to be just like scenarios that come up once in a while that you're not going to see in regular DNS management, but they come up. It's good to be aware of them as an exercise to kind of think through and really understand the concepts of DNS. And then the last two topics are going to be about some load balancing specifics, talking about like GSLB and layer 7 application load balancing and some of the other stuff that you can do with DNS for that. That also, we might talk a little bit about DNS policy that's available in Windows servers, but probably not widely used, and probably some of the drawbacks of using that system rather than enterprise load balancer solution like an F5 or a NetScaler. And we're going to wrap up by talking a little bit about DNS security, since it's actually a really good security solution to have something that's DNS based. So we're going to talk about some of the vulnerabilities there, but also some of the ways that it can be addressed. I'm going to go ahead and get started on the basics with this presentation. So I'm going to switch over to PowerPoint here quick. Let me just swap this. And I'm going to get rid of myself to go over this. All right. Cool. So let me do some tweaking here because I'm not seeing all of my screen. Hold on. All right. You know what? Just for the sake of presentation here, I'm going to do this quick and dirty. Gives me some more chance to see the cursor and then I can interact with things anyways. So DNS basics. Sorry, I'm doing this on the fly, so it's a little rough. So very first setup with DNS, obviously DNS client connects. It gets an IP address by DHCP, and in most scenarios, if it's a workstation or if it's a client that connects dynamically like that, it's going to get its DNS servers directly from the DHCP server. In this case, if a client needs to do a DNS lookup, whether it's querying the name of another workstation in its network or connecting to the internet and surfing web traffic, a request is going to go. It might go to a recursive DNS server. It might go to an authoritative one, depending on the zone you're looking up. We'll talk a little bit about that later, but it's going to go to a DNS server. It's going to say, I don't have this zone. If you're assuming you're navigating internet traffic here, it's then going to go to the root or servers or your forwarders to look up the address of the zone. That's going to tell you where to go for the address, and then you go check with the authoritative DNS server, which will return you the IP address and finally connect the client. So that, in a nutshell, is the basic DNS lookup workflow. And we're going to talk a little bit about the different scenarios that might change that. Specifically, the authoritative DNS server is what makes a difference in the workflow and how much traffic you have to navigate, and then also whether you're using route hints or forwarders, and we'll talk a little bit about that at the end section here. Moving on and talking a little bit about web applications. So when your traffic goes out to the internet and you're looking for a DNS record, let's just say you're looking for google.com as an example. Chances are you're not hitting an authoritative name server and it's returning one IP address because that's the only IP address that's available. A lot of big web applications that are international or hosted have to have multiple different data centers hosting different instances of them. In that case, you are actually going to connect to most likely a load balancer that's closest to you, and it's going to return the address of whatever connection server for that website's available and most optimal for you. And by that, I mean that if you are in North Carolina and you're connecting to a website like Google, it probably has servers available somewhere on the East Coast for you to connect to, probably somewhere in the vicinity of North Carolina. So there's going to be a load balancing element to that request where if you query for google.com, it returns an IP address of a server that you can connect to that is closest to your area. So it's important to think of DNS as the main factor in that, because the DNS record is just the friendly name of the website and it's transparent to you as an end user. But what's happening on the back end are processing or server logic to connect you to a point that's local to make that website connect quickly. So there are a lot of elements around it specifically for load balancing that we want to consider and keep in mind for DNS, because it really is the key that makes load balancing work. We're not going to get too deep into that in this topic because it's just a review, but I wanted to put this picture in mind of as you're working through this workflow where you're connecting to a DNS server and sending you to the internet to get traffic. Sometimes these authoritative DNS servers are not actually just DNS servers that are out there, they're actually load balancers that are providing logic around a request and returning an optimal route. The other portion that I like to point out with DNS is you can't have HTTPS without DNS. Now, HTTPS is required on the public internet now. You cannot connect to a website by default without using, unless that website has a certificate. And certificates, by definition, are bound to the name of the website. What I have here in this screenshot is I'm opening google.com, and you'll notice any HTTPS website you go to that's not going to be throwing an error is going to have this little lock icon in the browser or something indicating that that connection is secure, that that certificate has been validated. And this window will show up in Chrome or in Edge. If you click on the thing and click on the connection is secure, it'll show you the site that you're connected to has a valid certificate. It matches. And if you know anything about certificates, they're based on the name. So the DNS name for google.com is in the certificate that's connecting to, which is why the connection is HTTPS and therefore encrypted and therefore secure. So without DNS, you cannot have that encrypted connection because the only other way to connect to a server is using IP addresses. So DNS is the central vehicle that makes HTTPS work. It's also why it's strongly advised in your corporate environments to connect to servers using the server name or the fully qualified domain name, because there's usually some validation on the back end to say this server has registered with our controlled DNS environment and the DNS record is managed in the domain, so we know that this connection is secure. If you are only connecting to an IP address, there's no way for you to actually know what you're connecting to. It's just an address in the network that can be taken by anything. So while it's reliable for the most part, especially in small environments, it's best practice to always use fully qualified domain names or the names of things you're connecting to. And it goes back to this concept of HTTPS. That's protected. The name is protected as long as your DNS is reliable and safe and secure and everything like that. So it's important to consider DNS in a factor to encrypted connections and also just as security in connecting to things. Moving on, I want to touch briefly, because it's just a review of the basics of SOA records and NS records. It's good to know because that's kind of what those are the core records when you're talking about an authoritative DNS zone. You connect to when you look up a zone, you get the SOA record. The SOA record returns information like where the authoritative name servers are. It's got some information about the domain. It's not really important to know what's in there, other than there's a TTL of 6 hours. That's how long it's cached. But that goes hand in hand with the NS records, because the NS record is listed with SOA, and the NS records are the actual name servers that host the DNS records for that domain. So anytime you're looking up a domain, if you're deciphering root hints or forwarder, it's going to get an SOA record for that domain, and that's going to tell you the NS records and give you the rest of the information on how to connect and look up information for that domain. It's not like you're ever going to be manipulating an SOA or NS record if you're an Active Directory DNS integrated zone that's managed for you, as well as the name servers are managed for you because it's AD integrated. So domain controllers are going to be your name servers. If you're managing a primary zone or a zone that's not hosted in AD, you might need to tweak these, but chances are these are going to be transparent, not managed. It's just good to know what they are from the sense of understanding the workflow that's behind DNS. Moving on, we kind of already mentioned this, but when you're querying for DNS, there's two types of servers you're going to be getting an answer from. You're either going to connect to a recursive DNS server, in which case a server that doesn't have the answer but is willing to go look up that answer for you. To go back as an example, this slide shows the recursive DNS server. In this example that's pictured, let's assume the recursive DNS server in this instance is your domain controller, right? Your client connects to your domain, it gets your DNS server, that's the IP address of the domain controller. It's looking for the internet. It needs to say, okay, how do I connect to google.com? It checks with the DNS server for your domain. Obviously, your domain controller is not going to have a record for google.com, so it's going to send you to its next steps, whether that's your root hints or your forwarders, and then it will look up the results and return you the results that it looked up. That's the recursion element of it. It's saying, I don't own this zone, but I can find out what the IP address is for you, and I'll return that. So the recursive is kind of like your go-between server if you're looking for a domain. On the flip side of that, if you are connected to that domain, let's say your domain name is contoso.local, the Microsoft sample domain name that you see everywhere. If you connect to DHCP, you're given your IP address, you're given your DNS server settings. You are also usually in an Active Directory domain registering your DNS record with your domain controller. So client1.contoso.local is registering in the contoso.local domain, and it now has an A record saying client1 is at 10.00.10 or whatever your IP address is. Now, on top of you registering in that domain, every other workstation and server should also be registered in that domain for your Active Directory zone. So when you are looking for server1.contoso.local.com, that's a contoso.local record. You're querying for that because your domain controller owns the zone for contoso.local. It is authoritative. It is the source of truth for that zone. So it can respond with authority saying, I have that zone. Here's the IP address that goes with the record that you're looking at. So that's the only difference there between an authoritative versus a recursive server. It's authoritative server is the one has final responsibility for the zone that you're trying to look up. I believe I have that. Yeah, just the same chart duplicated here. So authoritative, you connect, you get a result. Recursive, you connect, that server gets the result for you, but doesn't necessarily have an authoritative response. All right. Last element here. So when you are configuring your Active Directory domain controller, you have to tell it what to do with zones that it doesn't know. So in this case, we're talking about this recursive setup here. There are two methods for that domain controller or that DNS server to recursively look up the results of a domain. I think the default method is to use root hints. Root hints are not necessarily the most efficient, but they work. Essentially, what a root hint does is you get this list, this giant list of root hint servers. I think they're like roota.microsoft.com. I don't know. It doesn't matter. But if your DNS server, your domain controller, if you're querying it for google.com and it doesn't know where google.com goes, rather than getting that, in order to find out what a name server is authoritative so it can get the information for that zone, it goes through what's called the root hint check, which you can see documented in this workflow here. Essentially, this client is querying for google.com. It checks with the root server. But the DNS server provides the location of the root server. The root server says, okay, it's a .com address. So I'm going to look up the .com server and figure out, okay, where is google.com going to be? That .com server is going to respond, okay, the Google domain is hosted on this server. So now you've gone your root server, which has nothing, to the com server, to the google.com server. So it's iterating through each section of that domain name to get you the response. And then typically that google.com entry is going to be cached on your DNS server and cached on the client, so it doesn't have to do that every single time. But if you are working with domains that have multiple subdomains, it's very possible that can be an inefficient process. So the alternative, and I think the preferred method, is to use forwarders rather than root hints. And I believe, do I have a forwarders chart here? I think it's the same thing. Oh, got it. All right. So this chart makes it look like it's super inefficient because it makes it look like you're just adding a server in between your DNS server and your forwarder, or your DNS server and the root hint lookups, which is kind of correct, but actually not as inefficient as it looks. Because what you're doing with a forwarder is, rather than using root hints where your DNS server is connecting to the root servers themselves and going through this process, your DNS server is right here, and all it's doing is it has external DNS servers specified. This can be your Google DNS, which is 8888 or 8844. It could be your Cloudflare DNS at 1111, or it could normally or often be your ISP DNS servers, because those are very common to use as well. But by using forwarders, what you are doing is taking advantage of that DNS caching mechanism, because rather than just caching the DNS requests that are coming in through your DNS server and looking up results in root servers, these external DNS servers are oftentimes have much larger database of cached records that have been queried by any thousands, tens of thousands, millions of users that are using that same DNS server. So rather than needing to constantly requery and go through that root hints process of discovering where the authoritative DNS server is for the zone you're looking up, it has a cache table of all those DNS records that it's referencing based on previous results from all of its customers, and can just return you a result that it's already looked up recently. So while it looks less efficient, oftentimes forwarders are going to be a little bit faster, assuming they're hosted on very robust infrastructure, which you can generally expect from an external thing. My preference is always to use forwarders because it does save you the root hint lookup. It saves the trouble on your DNS server, and it kind of offloads that to somebody else on top of making advantage of queries. So I've always advised people to use forwarders rather than root hints wherever possible. In our environment, we actually have root hints disabled because we don't want to ever have it going through that process at scale. The last little bit here that I listed in the slide, but I don't actually have a picture for, is conditional forwarders. Now, conditional forwarders are if you have a specific domain that you know you want to route traffic to. Let's say you are on the contoso.local domain and you have network connectivity to business.local Active Directory domain. Let's say it's in the same building, it's kind of a partner business, but it has its own separate Active Directory domain, but there's network connectivity and you want to be able to resolve addresses back and forth between the two domains. In that case, because it's a local domain, it's not going to be published externally. It's not going to have DNS available externally. So in order to be able to resolve names of clients that are on business.local, I don't want to host the zone on my DNS server, but I do want to designate where traffic for business.local is going to go. So in this case, you create a conditional forwarder for that zone specifically. So you'd go into your DNS server, your Active Directory domain controller, you'd say, create a conditional forwarder for business.local, and any queries that are for that business.local domain go to X and Y DNS servers. Essentially, you're configuring two forwarder IP addresses, but only designated to that specific domain. That's why it's conditional. It's conditional only to the domain you specify. The reason I'm calling this out, and the reason it's good to be aware of it, is there's mechanisms in cloud-based connections. Specifically, I'm thinking of private endpoints in Azure, which allow you to grant a PaaS service private IP addresses in your internal network so that you can access them internally rather than having to go out through the internet to get to them, which is a protection mechanism. Private endpoints rely on conditional forwarders for the domains tied to that PaaS service. To give you an example, if you're using a storage account in Azure, which is just drive storage, right? You can use file storage, blob storage, doesn't matter. Those storage accounts are accessed using account name .blob.windows.net, if I'm remembering that correctly. If I have a private endpoint, I need a conditional forwarder for blob.windows.net and pointing that to a private DNS resolver in my Azure tenant in order for this to work. That's how it's able to look up the addresses and determine that that's a private, you have a private endpoint for that resources versus needing to go to the internet. So I wanted to call out conditional forwarders. They're not exactly the same as root hints or forwarders, which are used to resolve any domain, but they are good to know of because you have control over designating specific domains that you want to forward to a different DNS resolver. Conditional forwarders are going to be talked about more as we get into the load balancing aspect of DNS, because there's elements and logics that can dictate the record that's returned to your client based on a number of factors, and it's good to understand that logic because that directly ties into conditional forwarders and how it's returning smart records to your client versus just a general one. We'll get into that later. So that's the overview of DNS basics. You should already be familiar with most of these concepts. It shouldn't be new to you, but we just want to cover them all and establish a baseline going forward as we get into some of these other more unique DNS situations. I hope the janky presentation wasn't too bad, but yeah, it's kind of easier, I think, from a resolution perspective on my monitors to just do things this way, and then I can kind of use the mouse to indicate the things I'm talking about since I don't have a whiteboard available. So our next topic that we're going to get into is more enterprise type solutions, which are like IP address management tools, IPAM, and yeah, that should be up in a little bit. Thanks.